Next, we're going to look at solving quadratic equations using the square root property, which says that if we have one side of an equation being squared, we can take the square root of both sides to help us along the process of solving. If we take a look at number 13, m squared minus 25 equals 0. Notice that the linear term is missing. There's no m by itself. We just have the m squared. If I can get that m squared by itself, which I can do pretty quickly by adding the 25 to both sides, that leaves me with m squared equals 25. Now that I have the entire left side of the equation being squared, I can take the square root of both sides to eliminate that exponent. But I have to remember that because I'm solving an equation, when I take the square root of the right side, I have to account for both the positive and negative values of the square root. So that's why I have to include this plus or minus. Simplifying, the square root of m squared gives me m equals plus or minus the square root of 25 is just 5. So my solution is plus or minus 5, which is just a shorthand way of writing positive 5 and negative 5. The same thing happens in number 15. I can solve by getting the c squared by itself. So I can subtract the 9 from both sides. In doing that, I have c squared equals negative 9. Again, I want to solve that by taking the square root of both sides, because the exponent and the radical will cancel each other out, equals plus or minus the square root of negative 9. Again, the radical and the exponent cancel each other, so I'm left with c equals plus or minus, I have the square root of a negative number this time, so I have to remember to include the imaginary unit. So this gives me c equals plus or minus 3i. For number 17, we still want to accomplish getting the y squared by itself, so I will subtract the 9 from both sides. My 9's cancel and I'm left with 4y squared equals negative 9. This time I have to divide both sides by 4. My 4's cancel and I'm left with y squared equals. Please leave your answer as an improper fraction. Leave it as negative 9/4. Don't change it to negative 2 1/4. Don't change it to negative 2.25. It's a little bit easier to work with the radicals if you have a single value in the numerator and a single value in the denominator of your fraction, and that's it. The reason is because when you take the square root of both sides, so I'll take the square root of y squared equals, taking the square root of a fraction is the same as taking the square root of the numerator, so I'll take the square root of negative 9, plus or minus, over the square root of the denominator. Okay, I'll say that again. Taking the square root of a fraction is the same as taking the square root of the numerator over the square root of the denominator. I only need the plus or minus one time. This simplifies then to y equals the square root of negative 9 we said was 3i, so that will be plus or minus 3i over the square root of 4 is just 2. So your answer is y equals plus or minus 3i over 2. The same process can be followed for number 19. We don't have a linear term. In other words, we don't have just a z by itself. The only thing we have is the z squared. So to get the z squared by itself, I can add the 32 to both sides. Adding that 32 to both sides cancels the 32 on the left, and I'm left with 25z squared equals 32. Divide both sides by 25. My 25's cancel. On the left I have z squared. On the right, again, I want to leave my fraction as an improper fraction. I do not want to change it to a mixed number. I don't want to change it to a decimal. I want to leave it as 32 over 25ths. Or 32 over 25 rather. This will make it easier to take the square root. So when I take the square root of both sides, I get the square root of z squared equals plus or minus the square root of 32 over the square root of 25. Taking the square root of a fraction means taking the square root of the numerator and the square root of the denominator. On the left, my radical and my exponent cancel, and I have a z. On the right, I have plus or minus the square root of 32. Well, let me kind of work in the middle here. The square root of 32 can be broken down into the square root of 16 times the square root of 2. I chose 16 because it's a perfect square. The square root of 16 is 4, and the square root of 2 just stays the square root of 2. So when I simplify my fraction, plus or minus the square root of 32 becomes plus or minus 4 square roots of 2. And that's all over the square root of 25, which is 5. So my answer is z equals plus or minus 4 square roots of 2 over 5. For number 21, we still want to use that same idea, that we have the entire side of the equation being squared. It's not that 2k is being squared and then minus 5 is being squared. It's the entire quantity, or that entire side, that's being raised to that second power. Because we have the whole side being raised to the second power, I can use that idea of taking the square root of the entire side. So I can take the entire side and put it under the radical, and I can set that equal to plus or minus the square root of the other side, which in this case is just 16. Taking the square root of this side, the radical and the exponent cancel each other out, and I'm left with 2k minus 5 over here. And then on the right I have plus or minus the square root of 16, which is 4. To continue to solve for k, I will add the 5 to both sides. My 5's cancel, and I'm left with 2k equals. It is customary whenever you're doing these types of problems to put the plus or minus in the middle of the two terms. So what I will really have is I'll start with the 5, and then I'll put the plus or minus 4 so that that plus or minus is in the middle. In a case like this where the 5 and the 4 are both constant terms and I'll be adding them together to simplify it a little bit, it's not that big of a deal, but it's still not a bad habit to get into, to put that plus or minus in between the two terms. If I divide both sides by 2, my 2's cancel, and I'm left with k equals 5 plus or minus 4 over 2. If I simplify this a little bit more, like we talked about, you can combine the 5 and the 4. That actually is the same as k equals 5 plus 4 divided by 2, and k equals 5 minus 4 divided by 2. Well, 5 plus 4 is 9, and 9 divided by 2 is just 9 halves. So one of my solutions is 9 halves. The other one, 5 minus 4 over 2, well, 5 minus 4 is 1, and 1 over 2 is just 1 half. So my solutions are 9 halves and 1 half. Again, the same ideas for number 23. I have the entire side of the equation is being squared. So to solve it, I can take the square root of both sides. That gives me the square root of the quantity n minus 3 squared. Whoops. I said squared, I wrote cubed. Try that again. The square root of n minus 3 quantity squared equals plus or minus the square root of negative 4. Again, we know now that the radical and the exponent cancel each other out. So I have n minus 3 equals plus or minus the square root of negative 4, which is 2i. The only thing left to do to solve for the variable then is to add the 3 to both sides. My 3's cancel, and I'm left with n equals. Again, like we talked about before, the best form is to put the plus or minus in the middle. So you want to write your terms in a way that keep that plus or minus in the middle. I'll start with the positive 3 plus or minus 2i. I can't combine these. These are not like terms. So 3 plus or minus 2i is my final answer.